All right, so tonight we're going to do solution development. Theory paper, but looking at practical questions around that. So what they've given us is an algorithm. So main thing with algorithm, remember it's not based on a particular language. So don't look too much into like when it says input name, then think, but there's no variable and then array and then input and see that as wrong. Same with begin while loop. You'll see this whole thing. While name not equal to done, begin while loop. So that whole thing you'll say, but it shouldn't look like this. Remember algorithm. So you've got leeway into words. Even if they ask you for algorithms, remember to try and steer away from language specific words like inc and dec, increment and decrement. It's very much language specific. If you want to use those words, maybe write them out. Say increment q and decrement q. Then that's also fine. But try to not use specific. And if you want to use like a for loop, sort of put it in words. Don't write the exact code. So they will actually, if they ask for an algorithm and you give exact code, they actually penalize you for that. So you have to, if they ask for algorithm, needs to go algorithm. If they do ask you like here at the bottom for the specific code, oh no, they did say pseudocode. Yeah, so when they ask for pseudocode, it should not be specific code. This is a nice question actually because it's basically the sort algorithm. So I love that. They basically just ask you to do sort and then just display the first three. So, okay, but let's not jump ahead. Okay, we're going to get to that. So they've given us this. So generally, depending on how your time allows, I might in a theory paper leave this question for last. So I would skip question 5 actually, go to question 6. Your last question is always integrated and it's just more theory. Starts with internet stuff and then it will have some networking, some software, social engineering. So I would do that because that's the stuff you studied. And once you're done with that, then you go back to this one. And then you see how much time you've got left. Generally, if you know your theory, the others should go relatively quickly and you should have a lot of time here. Then step 1 is look at the algorithm and try to figure out what's happening there. For now, we're not going to worry this. We're just going to go into the questions immediately. So they ask us, line 1 and line 2 shows variables that have been assigned initial values. So if you look here, line 1, highest average has been given a value of 10. So that's fine. Number 2 is input name. So there's no variable that's been given initial value. So line 2 here is wrong. This is a mistake in the paper. There is no line 2 that assigned a value. And then are these values correct? So when we're looking for the highest number, remember you don't know. You'll see it's about scores. Can you just assume the highest one is automatically 10? What do you guys think? No. So what do you think this should have rather been? Yes, because you're looking for the highest number. You actually want to give it a very low number. So are these values correct? Your answer is no. Motivate your answer with reference to line 1 and line 2. So line 1 should become highest average, should get a value of 0. Or if you went anything less than 0, if you went -1, that's also fine. So any number 0 or less that you assign to highest would have been fine. Line 2 should not be changed. Yes, talk to me. So so we're assigning initial values. So it's just the variable highest average has been created, but because it's a local variable, well, we don't know which variable it is. But with algorithms, you always want to initialize variables that we're going to use because if you follow the code a little bit on, you'll see total gets the value of the highest average. So if we didn't initialize it, what are we going to give to it? So that's, yeah, so now in this case, so if you didn't initialize it, it will get a random number. Some languages, if you don't initialize a variable, it gets a random value from the memory address. So I'm going to use Excel just now as well. So I could just as well quickly show you how this works. So you have to remember, like storage and memory and everything, think of Excel with these blocks, and that's where stuff is stored. So let's say you're opening Windows and it's running programs and stuff. So whatever you do, these memories, something will be put in there, then something will be put in there, and something will be put in there, and something will be put in there. So it starts filling it up. Now suddenly this space is not required anymore. Our computer works. Let's say we put the number 1, 2, 3, 4. We put those numbers and values there, there. Let's say that's sort of how it works. Yes. So now it tells the computer, listen, all these things are taken. But now later on it realizes, okay, these things are not required anymore. So then it says, all right, listen, it tells the computer, listen, you can use those spaces. Those spaces are open for you to use. Now what we do is if you, I just want to look for the, so now if you do that, and now we want to create a variable highest average. Then what the computer is going to say, it's going to say, all right, let's give this area. This is now going to become, and we're going to use this for highest average. I'm just going to make like another shade of orange. So this will now be used for that highest average once you create the variable. So now that value, but remember, these are all binary numbers. So it does have like an ASCII code to it, so there's a number. Now your highest number will have a value of 26,000,789,723, whatever, a random thing. So if you just use it and you just assign it, you're giving that random number to total. And that's a problem. So when you create variables that you're going to assign early in the program without giving them values, you need to first give them initial values. So initializing is very important. There's like most of the time you get marks for initializing your variables. So whenever in arrays questions, if they ask you to add something or highest or lowest or whatever, and you create a variable that you're going to use to get the total or get the average or get the highest or get the lowest or get the mean or the average or whatever, just give them starting values. Right? After you created them, start of program, just say all these ones, they get the value of 0, 0, 0, and this one gets a value of a blank string. Just initialize your values. However, if you go look at the memo actually wanted you to initialize total as well. Now, they sort of assume total is here, but total is not there. And this one just said that you needed to change line 2. Line 2 was fine. If you're inputting a name, because you're inputting it immediately, that is also initializing. So line 2 is actually fine. Only line 1 shouldn't be 10, it should be 0. And total is receiving a value the first time. You see, total is not on the right hand side initially. Highest average is on the right hand side. So you needed to give it a value first. But total not. So when the memo said you must also initialize total to 0, I disagree, because highest average is given. So at this stage, technically it is initialized. Yeah, just at line 4. So, which is fine. That is fine doing it. Well, you actually wanted this outside the loop, but we'll get to that just now. But so this, having this there is fine. I think the question needed to say line 1 and 4. And then, but still line 4 is fine, because once you make highest average 0, it will also give 0 to total. So assigning it there, initializing it there, fixes that one as well. And line 2 is fine. As I said, line 2 is just inputting a name. So with this question, the 3 marks should just go highest average must get a value of 0, or the answer no, and then highest should get a value of 0, and then all 3 marks should go towards that. If you did that with only that one, you can fight for the other mark. If sir says, yeah, total needs to be 0, you can tell sir, but sir, total gets the value of 0. So why do I need to say it there as well while it's already getting it here? There's no reason for it. So, yeah. All right, so that's that first one. Please, if you see questions, please ask me. Then 5.2. Besides line 1 and 2, there is another error with the pseudocode above. Write the line number and explain how to correct the error. So let's look at this thing. So we're going to assign 0 to them. We're going to get a name. We're going to check while that name is not equal to done, which is fine. So it means they're going to ask for names the whole time. And as soon as you type in done, it's going to stop. All right. Then we give that highest value to total. So total gets a value. Then we loop 3 times. We get a score. And we say the total must become whatever the total was plus score. So that is the algorithm for adding up. So that's 100% right. We need to know that one as well. They love asking this. There's something that just gave it to you. So total is equal to total plus score. So that's adding up all three of the scores, which is good. Then the average is the total divided by 3, which is fine because there was 3 numbers. So everything still looks good. If the average is more than the highest average, then we give that average to highest and we put that name into highest name, which all sounds good. That's legitimate. Everything sounds good. And now it ends the while loop. But remember, what was my while condition? My while condition was while the name is not done. Did name change anywhere inside of this loop? And no, it didn't. Only outside the loop by 12, they're asking for the name. So that is our problem. They're going to expand on this in 5.4 as well. But so with this one, we needed to realize the while loop. I'm going to quickly jump. Because I don't know, the sequence they ask the questions is not ideal. ITC, initialize, test, and change. That's ITC in this case. So, and there they said, write down the line number and indicate initialize, test, and change. So by doing that, you would have actually seen the problem. So our condition, you always start with a T actually. So our T, our test, is the condition, which is there. So while the name is not done, so which variable are we looking at? The variable of name. So now you must go look. So initialize tells you must initialize it before, which happens there. It's fine. That's our initialize, line 2. There's our test. And then it needs to change on the inside. And that never happened. It changed outside of the loop. And that's the problem. So ITC principle of a while must be followed. And our problem here is line 12 should be inside the loop. So that you can initialize it, you can test for it, and then that variable needs to be changed on the inside. So we need to remember that with all conditional loops, the ITC. So they want to identify line number and for the corresponding ones. Yes. So remember now look at this loop. So initializing. All right. So you always start with the condition, as I said. So you look, what is the condition of my while loop? The condition means it's checking if the name is not equal to done. So which variable are we comparing? Which is name. So that's my test condition. So the initialize means before the loop, I need to give name a value. So by inputting name, that gives it a value so that I can test it when I get to it. So now I and T is good. The C, the change must be inside the loop. So inside your loop, you need to change the condition variable, which is name. And that never happened. Name is not here. So inputting a name, putting that inside the loop, it means we'll get the name, then we can check if it's done. Then we get all the scores, work out the average, and then we have to ask, okay, what is the next name? So that we can check again. Is name equal to done now? If it's still not done, we work out an average again for the next person. And then, yes. So you want to go through, because what this one is doing, you'll see there, this algorithm is looking for the name and the average of the person that's got the highest average. So it does that check for you. So we need to get the next person's name to check if it's done. If it's not done, then work out his average and see if he's got the highest maybe, and then get the next person. No, 100%. Any conditional loop, try to always follow those 3 steps. Start with your condition, do the condition what you think when it should stop, and then go before the loop, initialize it, go inside your loop and change it, and then go look at the rest. But always do that. If you don't change on the inside, like in this case, who tells me if I run this program, what will happen? Okay, so what will technically happen? Somebody else wants to give me an option? All right, nobody. All right, so I'll change my question, maybe make it easier. When will this loop stop? After how many times will this loop stop? All right, anybody else? All right, no other takers. All right, so let's look at this. Look at this loop. This is while the name is not done. Okay, so let's say we get the first name, Pavan. We put Pavan. Is Pavan done? No, it's not. Putting in the highest, looping 3 times, getting the 3 scores, working out the average. We say that average is the highest from Pavan. We go back up. What's the name? The name is still Pavan. So is Pavan done? No, it's not. So now we get 3 new scores. Put it in, work out the average, look at the highest. Then we go back. Is Pavan done? No, it's not. So we get 3 scores, put them in, work out the average, get the highest. Come down here, we go back up. Is Pavan done? No, it's not. So we put in that, work out 3 scores, work out the average, go down there, go up there. Is Pavan done? No, it's not. So we go again, put in that, get 3 scores, work out the average, go there, come up. Then we say, all right, is Pavan done? No, it's not. All right, then we go in there. So will the name ever become done? No. So this is an infinite loop. This thing will carry on infinity-wise. Your program will actually hang. It will freeze. Because the name never changes. So it can never become done. So it can never stop. So this loop will continue infinity times. Because it doesn't matter what scores you type in. Every time the one that needs to stop it is the name, which doesn't change. So it will just ask for the next 3 names, 3 numbers again. And do that, and just the next 3 numbers and do that, and just the next 3 numbers and do it, and that will continue on infinity because the change part is not inside. So if your C part for a while loop is not there, you'll actually get an infinite loop. All right, everybody with me with that? All right. Okay, so besides line 1 and 2, what other error is there? So it's line 12. That should just be inside the while loop. So our end of while loop should just move down in between line 12 and 13. Then that's fine. So that's the second one, 5.2. 5.3, what type of error is explained here? Now, before we do this, there's 3 types of errors. Who knows what type of errors we get? What's the last one? Who can help up one? So it's correct. Syntax, runtime, and no. All right, the last one is a logic error. So that's our three different types of errors we get. Runtime, syntax, or logic errors. So the difference between them. Syntax one is your easiest one. You know when you try to play the program and then it says, no, you can't play it, and then it shows you like a red line. It says there's something wrong here. That's a syntax one. A syntax one is there's something wrong with your code that will prevent your program from running. So syntax error won't even let you run your program. That's our syntax one. So one line of your code is just coded wrong. A runtime error means your program will run, but as soon as you click on a certain button or activate a certain procedure, then the program crashes. So that is a runtime error. So the program runs until it gets to that stage, and then it crashes, or then you get an error. It could be like if you ask for the person for his age, and then you string to int it, but then the person goes and he types in 10, but TEN, he types in the word, and then in your code you went string to int. So then you actually get an error because the program cannot change a word into an integer. So those things are runtime errors. The code will run because it's going to assume you put in integers. But once the person then types in strings, it will crash because it actually wanted integers there. And then our last one, a logic error, is sort of like the word says. It's the programmer made something wrong. So a logic error is nothing wrong with the program. I want to say program inside inverted quotes, actually. Let's say I asked, let's work out the average of how many people's in your IT class? Pavan? Take a guess, like 15, maybe. Okay, 25. All right. All right, let's go 25. So there's 25 people. Now, let's say we want to work out the average IT mark for all of them. So we add up all 25 marks and we divide by 2. I get an answer. Is that the correct answer for the average class, the class average for IT? Who wants to tell me? Oh, okay, sorry. So let's say I want to work out the average IT mark for everybody in the IT class. So I add up all 25 marks and then I divide by 2. And now I want to check, all right, this is the average for the class. Would that be correct? No. Yes. So, and that is a logic error. Would the program crash? No, it wouldn't. The program can't know that that's a mistake because maybe he thought you just wanted to halve it. So that is a logic error. So logic error works fine. The program doesn't crash. Everything works fine. There's no errors. But your answer is just wrong. So if you sort, let's say I take the IT marks and I sort them from highest to lowest, and I want to see who's the best, and I take the bottom name. That will also be wrong. The program won't know because the program might think you want to display the worst person. He won't know. That's a logical error. Yes. Yes. 100%. A logic error is the programmer did something mathematically sort of wrong. It doesn't always have to be mathematics, but yes, the programmer just made a mistake. He programmed it correctly, but doing the wrong stuff. Sort of, if I can phrase it like that. Yes, syntax. If you leave out a begin or end, or you just misspell begin and end, or you misspell into string, or anything like that. So runtime, there's no coding errors. the program runs, but as soon as you activate a certain button, then you get the error. So runtime would be, like the example I used was converting. If you ask the person for his age, in your code, you said do string to int of this answer, because the guy's going to type in an integer. I want to have it as an integer so I can add 10 years to it. And now the guy goes and he types in the word TEN. So now you're trying to convert that to an integer, and now the program crashes because it says you can't convert a string, and that is a runtime error. All right, so now I want to know which one of those three happened here with this input being on the wrong side. Yes, perfect. Because this program will run, so it's not syntax. But the problem is it will freeze. As soon as it gets in here, the whole program will hang because it becomes in an infinite loop. And that is a runtime error. Because it just didn't display the wrong answer. It couldn't display anything. It couldn't do anything. It sort of hanged or froze your computer. And because of that, it's a runtime error. As soon as you activated this code, an error occurred. All right, then ITC we went through. And then I say line 3, write a Delphi code to make sure regardless of whether the user inputs are uppercase or lowercase, the loop terminates successfully. So by asking that, what do you think they actually wanted you to do? How can I check that doesn't matter if they type in uppercase or lowercase, the loop will terminate? So they want this one that we highlighted, but Delphi code for that so that it will stop, doesn't matter which way. If they typed in done in small letters, it would still stop it. It won't only look for capital letters. So that one basically looks while the name is not equal to done to begin. That's how that line looks. But now they want us to write this code, but so that doesn't matter what the person types in here. If it's small letter done or capital letter done or cap D and then small letters ONE, but it will stop the loop. Doesn't matter which way you type it in. What can we do to make that happen? Yes, perfect. It just means we want to uppercase the name. Because if you uppercase the name, remember then it will make it capital letter. So it doesn't matter what the person typed in name, it will make it capital letters to compare it with the capital letter done. And that will give you 2 marks. So you just needed the uppercase there. And then the last one, they wanted pseudocode. Pseudocode for sort. So they told us here, any questions? No, all right, all good. All right. So to sort the average scores calculated in the previous algorithm in ascending order, the average scores are now stored in an array called average array. For the first 3 positions of the array, display the average scores and the message in the middle was achieved. Array. Just see, did they tell us how many names were there? Athletes scores highest. Okay, that all happened. All right, so they didn't tell us how many are there, but all of them were stored in the array. So we can assume, let me just see both of the average. All right. Okay, so with this one, okay, I can delete this one. All right, so they didn't tell us how many elements are there. All right, so with this one, we don't know how many elements are there in the array, but, and they said the array is called average array. So you've got an average array. This is what we've got. And now they want us to write the algorithm for this. So who can help me? What do we need to know? Anything? What can you remember with a sort? Give me ideas. What can I type here? Yeah, perfect. You can just throw it, guys. Yeah. Yes, go for it. Tell me. No, so they told us here that they already got the scores, average scores from the previous program. So we've got an array with all of those scores already inside. So you've already got the array with all the scores in. We just need to sort this. We're just sorting, and then they want the first three to be displayed, which is fine. But that happens after we sorted it. We can just display the first three, so that's fine. So basically, we want to sort for now. Pseudocode's more English, so you can say this should be a for loop. There should be a for loop. But I want to say, if you can think of the Delphi code, if it's easier, most of the time for people it's easier to write the Delphi code. And I want to suggest to you, write the Delphi code then first, and then you can sort of just um, make it more English afterwards. So tell me, what would you do in Delphi code or pseudocode? Anybody, you can just tell me, like, what must I go in, what must happen with these loops? What must happen in the if condition? What should happen inside the if? And then, yeah, we take it from there. All right, so remember, you won't necessarily know there's only three inside. There could be more than three. So we didn't know. So say something like number of elements. What you could also do maybe before, to make your life easy, you can say Q is equal to number of elements in average array. And then you can just go here from 1 to Q. So make a for loop that takes, I should start at 1, I must go to Q. All right, and what else? Yes, we can. Thank you. Yeah, that's good. The, the main thing with this, if you leave out the begin and ends, as long as you use your indentation, that's also fine. But it's always good to have them, but always use the indentation as well. A lot of times there's a mark allocated for indenting. Look where I start. So this for loop started against the line. This for loop starts there. That for loop starts there. Now, because I'm inside this if, I'm going to start inside again. Yes, exactly like Delphi. Every time you've got a begin or an open bracket, basically, you go one step inside. And as soon as we end it, we go one back. All right, so what do I do inside this if now? Okay. That's the end. Yeah, and that is our sort. So that one they've given to us. So you don't need to write that. I just like putting it down there because we know that's what we've got. And then just any other variables you need. You'll see I didn't say int q. You don't need to create variables. You just assign values and it will automatically be the right value. The same with I, we didn't create any variables. You just use it as if it's correct. For loop j, then your if array, comparing, which is all correct this way. And then we end all those ones. So that's the sorted. But then they want the average scores are now sorted in the array, called that. For the first three positions of the array, display the average score with a message indicating the middle. Oops, I don't want this one. So they even told you just for the first three positions. So then you just say display, and then you can say gold is awarded to, and then we just say your average array. Let's see, so the average scores calculated that. The average one was sorted that. For the first representation, the array display the average score and a message indicating that that was achieved. So then it's just that one at position 1. And you just do this for all of them. I just wanted this 3 times. So that's 1, that's 2. This one's 3. You say bronze, silver. And that's all you needed to do. Right. So a question you could also get is just with loops. So a while loop is a conditional loop. A for loop is unconditional. You could get some questions then. What differences are there between a conditional and an unconditional loop? Which one is that now? For loop. Oh, the while loop. Okay. So a conditional loop runs unlimited amount of times according to the code, but the user will have the choice to, or the condition will let it stop once the condition is met. While a for loop or unconditional loop runs a fixed amount of times. Do you agree? So unconditional loop runs a fixed amount of times, while a conditional one, it could vary depending on the circumstance. So the condition will at certain stages run a certain amount of times and at other stages more or less. You could also say, if you want differences, you go basics in like a conditional loop uses the word while and an unconditional uses for. That's a difference. A conditional loop, like while, needs to be followed by ITC. You need to initialize, test, and then change. While a for loop does that all in one. You know, in your for loop line, it initializes your I, it's got the condition, and it increments. So all of your ITC happens in the one line. While with a while or a repeat loop, you have to physically code those separate sections. So that could also be a difference. Then the other type of question could go, what differences are there between a while loop and a repeat loop? Oh, nothing. All right, so the while loop, where is the condition in a while loop? At the top or the bottom? Yes, at the top. Remember, it's while and then condition, and then it only starts with the while. With our repeat loop, it's at the bottom. It's repeat all the code and then until with condition. So the difference between them, the repeat one, the condition is at the end, while in a while loop, the condition is at the start. What else do you think with the condition itself? What's the difference between the conditions? So a while loop, you get the while the condition is true, carry on running. So the while the condition of the while loop is true, it carries on with the code. But the repeat condition is a stop condition because it's a repeat all of this code until this condition is true. So our repeat loop, the condition is actually a stop condition. But with a while, the condition is actually a carry on condition. So while this condition is true, carry on with this code, but repeat all of this code until this condition is true. So our repeat until has got a stop condition, while our while has got a carry on. Another difference, just basics again. While loop uses the word while with a begin and an end. And our repeat loop uses the words repeat and until, and it doesn't have a begin and end. The words themselves counts as a begin and end. So that's all differences you can mention. You can even go this route ITC. A while loop needs to have his variable or his condition variable initialized, while with the repeat loop it's not that critical. So anything like that could work. You could even go further and say a repeat loop will always happen once. Because you remember, you repeat and then you do the code and then it only checks. While with a while loop, it checks first. So the possibility of not happening at all is possible with a while loop. The minimum amount of times it could run is 0 times for a while loop. If your condition is wrong at the start, like with this one we did here, if the first name the person types in is done, it won't even do this once. But if it was a repeat until, and the person typed in done, it will still happen once at least, and then only checks. No, so you must, even with theory papers, you must think open. My grade 12s had a question now from a common paper where it asks the mouse is not working. So suggest a way for the person to fix it, but without buying a new mouse. Then literally you could go anything from just putting the computer off or restarting the computer. It could be just move the mouse to another USB port. It could be checking the batteries or changing the batteries in your wireless mouse. It could be changing your mouse pad. Maybe the mouse pad was shiny or didn't work good. It could be anything from, what else? Just cleaning the sensor of the mouse, cleaning the surface of the mouse pad. All of those answers are correct. So you can always look at the question and think out of the box. That's the one thing I love about IT. We do ask sometimes open questions, and like this, it is a difference saying that a while loop starts with a while and a repeat until loop starts with a repeat. It's a difference. Anything that goes that route, it is literally a difference. In theory, I also had the question, differentiate between storage and memory. So the general answers that I was looking for was memory is faster, memory is smaller, memory is volatile, um, and stuff like that. But then one of my students went and said memory goes into DIMM slots while storage connects with SATA ports. It's a difference. So I gave him the marks. It's creative thinking. Just telling me where they connect to, it's a difference. So why should I not give the question the marks? So 100%, you'll get it. It must be correct though. So, but yes, yeah. I mean, if they ask for differences, if it is a difference, it's a difference. So, and yes, as I said, I've been marking IT grade 12 papers for like more than 10 years. And we accept those ones because it's a difference. It's one of the alternatives. So they learned out of their mistakes and they do try to narrow down the questions a bit. But if it's left open, remember I think every 3 years, they appoint a new examiner, a new person setting the next 3 years papers. So with that, if it's the person's first year, something like that could creep through where he leaves a question a little bit open. And then there's a lot of alternatives. So yes, you can do that and they will accept it. All right.